Hey Algebra 2, it is Mr. Lunieski. Sorry I couldn't be there today, but today I'm going to go through the notes with you on this video here. So today we're going to be talking about completing the square and the quadratic formula. Completing the square, something new, quadratic formula, hopefully something you've seen and done before. So we're going to talk about this method called completing the square, which is something that we're going to use when we have a perfect square trinomial. It's something that we can isolate, and we turn that into what is called the square of a binomial. So I have some examples here of what exactly that looks like. If we have a square of a binomial, so if I had something like x plus 3 squared, I want to remind you that that basically is like doing x plus 3 times x plus 3. And then when we do that distributive multiplication, x times x gives me x squared. X times 3x is 3x, 3 times x is 3x, 3 times 3 is 9. When we combine like terms, we get this. So this is called a perfect square trinomial. It's whenever we have a binomial and we square it. So something that I want to kind of give you as a hint, that if I give you a the square of a binomial, what you're going to do are these following steps. Step 1 is you are going to square the first thing. Step 2 is you are going to double the product. I'll explain what that is in a moment. And then the last thing is that we're going to square the last. So here we sort of have an x as our first thing and a 4 as our last thing. So whenever I do square of binomial, you can just factor it out this way, but if you remember these 3 steps, it's kind of nice and easy. So x, I square the first thing, so when I square x, that becomes x squared. Double the product means you're going to take this x times that 4, and it's technically a negative 4 here, so x times negative 4 is negative 4x, and now I'm going to multiply that by 2, giving me negative 8x. And then negative 4, when I square that, that's going to give me a positive 16. That last term should always be a positive number because we're squaring something. So for this next one, if I square the first, double the product, square the last, I get x squared. The product is 6x. 6x times 2 is positive 12x. Square the last thing, that gives me 36. So how do I know, what can I use this for in terms of working backwards? If I give you the perfect square trinomial, how can I go from this to this? And so the idea here is, if you look at this middle term, and let's go back up to these examples, if you look at the middle term, you can kind of see, well, how do I get from a 12 to a 6? How do I go from negative 8 to negative 4, 6 to positive 3? So hopefully when you're looking at that, you're realizing that we're taking this value, we're going to call that the b value, because all of these are in the format ax squared plus bx plus c. So this value of b, we're basically dividing it by 2. And then it's just squared. So here, if I divide negative 20 by 2, I get negative 10, and then that's going to give me this. And so if you think about that, if I square the first, x squared is x squared, double the product, negative 10 times x is negative 10x, times 2 is negative 20x, and then negative 10 squared gives me that positive 100 right here. And so you can kind of just remember that we're going to take this b value and divide it by 2. So this last one here, if I took the b value and divided it by 2, that's going to give me x plus 15 squared. Now I can't just jump into any old problem and say, oh, take the b value and divide it by 2. Basically we have to have a squared value here, and our c value has to be a perfect square number. So if you notice, 9, 16, 36, 100, 225, these are all perfect square numbers. Okay, so completing the square. We didn't really jump into what exactly that is just yet, but we're going to kind of walk through the steps on what this looks like. Forgive me if this video is a little wacky. I'm writing on a tablet and it's being kind of kooky. Alright, oh geez. This will be fun. Sorry. Okay, so let's look at this problem. If I look at this problem here and I want to complete the square or factor this, notice that 2, my c value, is not a perfect square, so I can't use this square binomial thing. But the idea is that we're going to transform the problem so that we can do a square binomial. And so what we're going to do is we're going to leave everything as is, but we're going to move that 2 over to this side, right? We're going to subtract 2 from both sides. And leave a little gap here because we're going to kind of fill in something on that point in a moment. So what we're going to do now, we kind of said up here that, well, if I take my b value and I divide it by 2, that's going to give me this idea of a square binomial. And what we're going to do is turn this into a square binomial by taking our b value of -4, we're going to divide it by 2. And so when I take that b value and I divide it by 2, that's going to give me -2. And then we said that basically if I take that value, right, this -10, that +15, and if I square it, that gives me the number of the c value. So now I'm going to take that -2 and I'm going to square it. When I square it, that gives me +4. So I have to balance out my equations here. So if I add 4 to the left side, I have to add 4 to the right side. So I'm still balancing things out. Now what I've done is I've created a perfect square trinomial here. So what I'm going to do is I'm going to turn that into the square of a binomial. And if you remember, that square of the binomial is going to be in the format x plus b divided by 2 squared. So now -2 plus 4 over on the right side gives me +2. And now I'm going to solve for x. Remember, we want to solve for x in these problems. So if you look here, think back to our rational unit, I'm going to square root both sides. When I do that, I need to remember to include a plus or minus because I'm physically adding the square root to both sides. And then I'm going to add 2 to both sides. So that 2 looks like this. It doesn't go in front of the square root. That is when we're multiplying or dividing. Since we're just adding the 2 to both sides, it kind of goes before the plus or minus. So then this would be our answer for that completing of the square. So what the heck did we just do? What are the steps to completing the square? That's what we're going to look at up here. So for completing the square, here are the steps that we're going to follow. Here we go. What's going on here? So the first thing that we're going to do is we're going to move the c value to the right of the equal sign. Then we're going to add b divided by 2 squared to both sides. And then we're going to factor the left side as the square of a binomial. Keep in mind that that should be in the format x plus b divided by 2 squared. Then we have to square root both sides at one point, so please don't forget your plus or minus, and then just solve for x. So the idea is that this is a method that we use whenever we can't technically factor something. So last class we kind of looked at some methods of factoring. And what if we get to a problem where we maybe can't factor? We can try this complete the square method. So looking at this problem here, I'm going to go ahead and do this as completing the square. Also, I want to remind you at any point if you need to pause the video or rewind to listen to another problem again, feel free to do that. So the first thing, again, we're going to move c to the right of the equation. So I'm going to subtract 1 from both sides, giving me x squared minus 4x equals -6. I tend to kind of like to leave a little gap here. I didn't leave myself a great gap. Let me fix that. Just because we have to balance out, right? We're going to add something to both sides of this thing. So in this problem, my b value is -4. So -4 divided by 2 is -2. And when we square that, we get +4. So again, we are going to add 4 to both sides. So when we do that, The x squared minus 4x plus 4, we're going to turn that into the square of a binomial. Remember, the square of the binomial is going to look this format, x plus b divided by 2 squared. So we said that b divided by 2 was negative 2, so this is going to become x minus 2 squared equals, and then negative 6 plus 4 is equal to negative 2. Square root both sides, so when I do that, I get x minus 2 equals plus or minus the square root of negative 2. Hopefully, something's going off in your head telling you, wait, that doesn't seem right. If you remember, we can't square root negative numbers, so this, when I add 2 to both sides, we need to handle this negative square root of 2. So I want to remind you that negative square root of 2 is equal to the negative square root of 1 times the negative square root of 2, and that negative square root of 1 is equal to I. So this problem simplifies to 2 plus or minus I square root of positive 2. So you do need to simplify those negative square roots into imaginary solutions. Alright, let's take a look at another problem. So for the next one, number 3, what we're going to do is same thing. We're going to move this c over to the other side. So that gives us x squared plus 14x, leave a gap, equals 51. Our b value here is 14. 14 divided by 2 is 7. Square both sides, we get 49. So I'm going to balance out and add a 49 to both sides. When I turn this into the square of a binomial, it becomes x plus 7 squared. 51 plus 49 is equal to 100. Square root both sides. The square root, excuse me, the square root of 100 is plus or minus 10. So notice we have a whole number here. So we're going to subtract 7 over from here, but we're not just going to leave our answer like this, right? We need to actually work this out. So we're saying negative 7 plus 10, that's going to equal 3, and then we have negative 7 minus 10, which equals negative 17. So notice our answers actually came out to be pretty nice whole numbers here. If you get a solution like that, that actually means that this problem could have been factored the normal way, what we did before we took the quiz. We didn't have to do completing the squares here. We really could have just factored this normally, but that's okay. Completing the squares still works. We still get the same answer. So, you know, these are just kind of methods that we can use. If you take a look at the next problem, notice on this one we have a number in front of the x squared. So as always, we want to be looking for that GCF. That should always be our first step. So for this, we actually can factor out an 8, divide everything here by 8. Now because we're solving for x and we're not just simply factoring this thing, we don't need to bother writing the 8 anywhere. So this now becomes x squared plus 2x, and I'll leave a gap, is equal to 6. So now we're going to complete the square. Our b value is 2. 2 divided by 2 is 1. Don't forget to square it. So now we're going to add 1 to both sides. So we get x plus 1, squared is equal to 7. Square root both sides, we get x plus 1 equals plus or minus square root of 7, and then we subtract 1 from both sides. And we get that as our answer. So this is just a method of factoring. Some of you may take to it, some of you may not, and that's okay. There aren't going to be too many situations where you're forced to use completing the square. So that leads me to the next thing. The next thing is the quadratic formula. The cool thing about quadratic formula is that you can always use this. You can use this formula for every single problem on the test. Basically, any kind of question that requires you to factor, you can always use this formula. I want to remind you that these equations are in the format ax squared plus bx plus c. So if you notice in the formulas, we have some B's, some A's, and some C's. So that's what this is referring to. So we're going to look at these problems here, and we are going to use the quadratic formula to solve for x. For these ones, we need to make sure that they are set equal to 0, so kind of the opposite of what completing the square was doing. So for this first one, it is set equal to 0, so off to the side, I usually just like to jot down what my a, b, and my c values are. A is 1, b is 4, c is 6. So we're going to do minus b plus or minus the square root of b squared minus 4 times a times c, and then we're going to divide all of that by 2 times a. Realistically, you can type all of this into the calculator, except you can't get that plus or minus feature on your calculator. I don't want decimal answers as this stuff though, so that's the downside with the calculator, is that if you type it into the calculator, it's going to give you a decimal, so I won't accept that as an answer. So what I typically do is I will sort of simplify the inside of the square root. This is called the discriminant. So 4 squared is 16. 4 times 1 times 6 is 24. 2 times 1 is 2. Now I'm again just going to keep simplifying what's inside the square root. So inside the square root I get negative, what is that? Negative 8. 16 minus 24 is negative 8. Divide by 2. Notice we have a negative 8, so we need to simplify that radical. Remember using our little factor tree. So because we know it's a negative, we're going to be able to pull an I out from that. But positive 8, if you remember our factor tree, 4, 2, 2, and 2, we're looking for a set of 2 here. So this simplifies to plus or minus 2i square root of 2 divided by 2. So again, the square root of 8 simplifies to 2 square root of 2. And then because of that I, I'm going to sneak that I in because it was negative. But we're not done. If you notice here, each number that is outside the radical is divisible by 2, and so we're going to divide each of those by 2, giving me a final answer of negative 2 plus or minus I square root of 2. If you want to put a 1 in front of that I, that's awesome. Okay. So, looking at the next problem, going to do quadratic formula. Notice this is not set equal to 0, so don't jump right to the formula right away. We're going to rewrite this as 2x squared minus 5x minus 12 equals 0. I'm just moving all the stuff from the right side over to the left. So here we have a is equal to 2, b is equal to negative 5, and c is equal to negative 12. So, be careful when you're substituting into the quadratic formula. Notice, it's negative b. Well, when I substitute my b value in, it's now minus negative 5. So that's going to end up becoming a positive 5. So just keep that in mind. Same thing here. Be careful when you are squaring. Just be careful with the calculator. In particular, just remember that a negative number squared is always going to be positive. And then divided by 2a. So again, I'm just going to kind of go through and clean this up a little bit, simplify these pieces. So negative 5 is going to be positive 5, plus or minus negative 5 squared is 25, and then 4 times 2 times negative 12, that is going to give you negative 96, but then there's already a minus sign there, so that's going to become positive 96. And then we're dividing by 4. So now this becomes the square root of 121, which is then, that becomes 4. Square root of 121 is a perfect square, so that comes out to be 11. Again, we're not just going to leave our answer like this. Because we're getting nice whole numbers, we can actually simplify these things. So 5 plus 11 is 16 divided by 4. 5 minus 11 is going to give me negative 6 divided by 4. So I'm going to get two answers here. One answer is going to be that x is equal to 4. The other answer is going to be that x is equal to, again, do not give me a decimal. Instead, give me a simplified fraction. Where do we get that? Alright, you may want to take a little breather here from the notes, maybe pause, do a little stretch or something. We're going to move on to the back of the notes now. Alright, we're going to talk about something called the discriminant. I sort of name dropped that earlier in the video. The discriminant is a specific part of the quadratic formula. I like to have the square root underneath it. You don't have to have that there, but I like to have it there because I think it helps me remember what the solutions are. So the discriminant is used to help you determine the number and types of solutions that you're going to have. So there's essentially three situations that can occur when I do b squared minus 4ac. We actually saw two of them on the front of the worksheet. If you look here, on this problem, we ended up getting a negative number. We got -8 in the discriminant, and on this problem we got positive 121 as our discriminant. So basically things that can happen is we can get positive numbers, negative numbers, or we can get 0. And so what that tells us is that if we have a positive discriminant, that's going to tell us that we are going to have two real solutions. We're going to have two numerical solutions that we can have. If we have a negative discriminant, that means that we're going to have two imaginary solutions. So again, if you look back at the front, when we had that -8 in our discriminant, we ended up having I in our answer. On the second quadratic formula problem, when we had the positive 121, we ended up having two real numbers that we had as our answers. We didn't see an example where the discriminant equaled 0, but if the discriminant equals 0, basically the quadratic formula, this part sort of just cancels out, and so we're really only going to have one real solution there. So some of the ways you can say this is two real solutions, one real solution, or no real solution, or you can say two imaginary solutions. I kind of like the idea of two imaginary solutions, but either one of those is appropriate. So we're going to take a look at how can we use the discriminant to just do these problems. So I am not asking you to solve these problems. I am simply just asking you to tell me the nature of the roots. So I want to remind you that roots, zeros, solutions, all those things mean the same thing. So all we're doing is just finding the discriminant. So similarly, we're going to add 5 to both sides here, kind of like what we've done before. And then we're just going to figure out what our discriminant is. So here our A value is 7, our B value is -11, and our C value is 5. So the discriminant, again, you don't need the square root, but I like the square root because sometimes if you remember, oh, it's a square root of a negative, that might trigger the imaginary part for you. Okay, so it's b squared, so that's going to be -11 squared minus 4 times a times c. So that's going to give me 121 minus, let's see, that ends up being 140. So when I do that, that's going to be the square root of -19. So again, you don't have to solve anything here, you just have to go, oh, my discriminant is negative, therefore this is going to give me two imaginary solutions. So that's describing the nature of the roots. That's all you got to do for those. You don't have to solve anything. So for this one here, A is equal to 1. Whoa, what happened there? Sorry about that. A is equal to 1, B is equal to 22, C is equal to 121. So using that discriminant, we're going to say 22 squared minus 4 times 1 times 121. This is going to give us, 22 squared is 484, and then 4 times 1 times 121 is also 484. So this gives me the square root of 0. So since I have a discriminant of 0, what is the nature of the roots? That I have one real solution. Moving on, down on this one here, we have our A value is -5, our B value is 8, and our C value is -1. And so for that, using the discriminant, we're going to do 8 squared minus 4 times a times c. And that is going to give us 64 minus 20, which gives me the square root of 44. Now again, you don't need to simplify square root of 44 or anything. You just need to look at that and go, oh, that's a positive number. Positive number gives me 2 real roots, or 2 real solutions. Number 4, I would like you to try on your own, see what you come up with. I will let you know that the answer for number 4 is 2 real roots, but go ahead and try that one on your own and see what you come up with. Alright, the last thing we are going to do, thank you for sticking with me, is working backwards. We've been looking at problems where I give you an equation and you solve for x. What if I give you the answers to x and ask you to write the equation? So we're going to look at what that looks like. So a couple things I want to remind you about is that when we find x, what we're really solving for are called the zeros. The zeros and the factors were always opposites of each other. If you remember when we first looked at stuff like this, we said, oh, what was the value of x? We said, oh, it was -3 and -2, right? So they were sort of opposites. Like if it looked positive here, it was negative here. So just keep that in mind as you do these types of problems. So for this one here, what you're going to do is, when I tell you that x is equal to -3 and +2, basically I'm saying this. And now we're going to work backwards through that. So now we're going to set this equal to 0. So to do that, I'm going to add 3 to both sides. So that gives me the factor of x plus 3. This I'm going to subtract 2 from both sides. So that's going to give me the factor of x minus 2. And now we're going to put the puzzle together. So I had said earlier that we were pulling the puzzle apart in kind of some of the other earlier lessons. Now we're putting the puzzle back together. X times x is x squared, x times -2, -2x, plus 3x minus 6. Combine like terms there, and we get this as our answer. So this would give us solutions of -3 and 2. Technically, we should say that equals 0, I guess. Alright, so now we have one that's kind of weird with fractions, right? And so if you remember, when we have something where it equals a fraction, that means that we had to do a bottoms-up problem. So what I'm going to do is sort of start by moving the denominators over. So this is now going to become 4x equals 3, and this is going to become 3x equals -2. Now, to set these equal to 0, that's going to give me the factors of 4x minus 3. This is going to give me the factor of 3x plus 2. So anytime you see a fraction in the solution, don't forget about bottoms up, where you have to take the denominator and move it up into the numerator. So then this 4x times 3x is going to give me 12x squared. 4x times 2 is going to give me 8x. -3 times 3x is going to give me -9x, and -3 times 2 is going to give me -6. Combine like terms here, that's going to give me 12x squared minus 1x minus 6. Alright, 2 more to go. So these ones, if you notice on these ones, I don't have 2 solutions. That's because it's sort of a hidden solution. So anytime you have a rational or an imaginary number, it's sort of 2 hidden solutions. And I want to remind you of the conjugate. I can't spell right now. Conjugate, I think, is how you spell that. And that was the idea of, well, if this is x plus square root of 2, or I'm sorry, 3 plus square root of 2, that the conjugate of that was 3 minus square root of 2. So it's sort of understood that those are the 2 solutions. I'm actually going to change this problem to, instead of being 2 minus 3i, I'm just going to make it -3i. So then it's sort of understood that 3i is also a solution there. So for this problem here, keep in mind we're basically just setting these equal to x and then subtracting everything over. So for this first one here, this would come out to be x minus 3 minus square root of 2. So this one's going to look a little weird. We're going to end up distributing 3 parts instead of 2. This factor here, imagine again this was set equal to x. This is going to be x minus 3 plus square root of 2. So for this, I'm going to kind of rewrite it down here. Here's what my factors look like now. X minus 3 minus square root of 2 and x minus 3 plus square root of 2. So now we're going to do that distributive multiplication, but instead of doing it with 2 pieces, now we're just doing it with 3 pieces. So that becomes x squared minus 3x plus x square root of 2. Distribute the negative 3. That's going to become negative 3x plus 9 minus 3 square root of 2. And then distribute the negative, the negative square root of 2. I'm just going to kind of rewrite down here. So this becomes negative x square root of 2. This is going to become positive 3 square root of 2. And then negative square root of 2 times positive square root of 2 is going to be negative square root of 4. Notice how I kind of wrote these down because they're sort of like terms. Notice that these cancel out. Square root of 4 is 2, so technically I'm subtracting a 2 here at the end. And so this becomes x squared minus 6x. 9 minus 2 is 7. So you should get x squared minus 6x plus 7. And then this last one with the i's. So we're going to say x plus 3i and x minus 3i. X times x, x squared. X times negative 3i is negative 3ix. Or you can say 3xi. Positive 3ix. And that's going to give me negative 9i squared. Notice the 3ix's cancel out. So we are left with this. As a reminder, I squared is equal to negative 1, so we need to substitute a negative 1 in for that. Negative 9 times negative 1 is going to give me positive 9. And so this is our answer. Alright, thank you so much for watching the video. Again, go back and rewatch anything that you feel maybe I went a little too quickly through. We'll review over this a little bit when I get back. Thank you for watching. Enjoy your day.